Hi guys, today we're going to spend a few minutes talking about perimeter area and volume. This is going to be review for you. We're going to add on the fact that we are not going to be using whole number parts anymore. We're going to use decimal and fraction parts. So the I can statement, I can find the area, perimeter, and volume of figures with fractional dimensions. So let's begin. Quick review, perimeter. Perimeter is the total distance around the outside of a shape. So if I were to start right here and walk around a shape, and I would just measure simply how far did I travel. So in order to do that, I just add up all my sides. In this case, I get 26 inches. Now notice my units are exactly what's given because I am just simply measuring how far did I travel around this, in this case, the rectangle. Okay, so let's give it a shot. Pause the video, try this one, and then press play. Okay, let's see how you did. You should have added up all the sides, 12 plus 25 plus 12 plus 25, and gotten 74 centimeters. Don't forget your units. Some of you might have done 12 times 2 plus 25 times 2. Or some of you might have even said, well, what if I do 12 plus 25 and then double that because everything has a partner. That's fine. Actually, that is approaching the distributive property, which we will spend a lot of time talking about this year. So if you did, you're off to a great start. Let's talk about area now. Area is, unlike perimeter where we measure around, area measures what the space inside. And in this case, when we're talking about area, we're talking about how many square units fit inside of something. So that's going to change our units to units squared. And we'll talk about that in a second. Just a reminder, there are a few formulas that you'll need to know. For example, the area of a rectangle, which is also the area, formula we use for the area of a square, or could use for the area of a square, which is length times width. The area of a parallelogram is also length times width, and that would also go for a rhombus, okay? Because a rhombus is just a special kind of parallelogram with 4 equal sides. The area of a triangle is going to be length times width and then divided by 2. And now let's talk about that. So if I wanted to calculate the area of this rectangle, I would simply just multiply 3 times 12 to get 36 square yards. Now you could also write 36 yards to the second power, or yards squared. Means the same thing. So there's 2 different ways you can write this. But that's because if I had 3-inch or yards going down this way and 12 yards going across the bottom, and I would count the squares inside, I would have 36. So 3 rows of 12. How about this parallelogram? Now, be careful with parallelograms and rhombuses. And this is kind of going to apply to triangles too, but we'll talk about that in a second. This length here is 13 feet. So if I wanted to find the perimeter, I would need to know the length of this. But when I'm talking about height, because remember, base times height or length times width, I'm talking about how tall does it stand off the ground. And in this case, it's 11 feet. So when I go to calculate the area of this parallelogram, I'm going to multiply 7, my base, times 11, my height, to get 77 square feet, or again, you could write 77 feet squared. That's also fine. For a triangle, again, like with the parallelogram and rhombus, the base is what it's sitting on. So it is sitting on this 9-centimeter space here. The height is how tall it stands off the ground. So I'm going to use 4 centimeters as the height, 9 centimeters as the base. This 5 centimeters is referring to the length of this side, and 7 centimeters is referring to the length of that side. Those are not considered when I'm talking about area. Only the base and how tall it stands off the ground. Think about yourself. If you are standing up straight and you move your arms being that are moving are not changing your height from toe to head. Okay? So base times height, 4 times 9. Remember, because it's a triangle, we need to divide that by 2. So we get base times height divided by 2. 9 times 4 divided by 2 is 18 square centimeters, or 18 centimeters squared. Both of those are acceptable ways to write your units. All right, let's talk about volume. So the volume of rectangular prisms, and that's the only three-dimensional solid that we're going to focus on in 6th grade. And we're going to get a little more challenging with this when we get into our fractions unit. So using cubic inches, we can build a rectangular prism that is 3 inches long by 2 inches wide by 5 inches tall. So here we go. Here is my 2 by 3 cubes. Notice these little things that I'm building with, these cubes have a base, have a height or length and width, and a base, a width, and a height. Okay. All right, so here we go. This is one of my 3 by 2s. And since it's 5 inches tall, I'm going to stack 5 of these on top of each other. So there's my second, there's my third, there's my fourth, and there's my fifth. Now altogether, each of these layers, you may have noticed, had 6 cubes. Okay, because 3 times 2 is 6. And I repeated those 6 cubes 5 times in my stack. So what I have here is a 3 times 2 times 5, base times width times height, which gives me 30 inches cubed now. Because I'm not counting the squares inside, I'm counting the cubes inside. They have 3 dimensions, so my exponent in my units is going to be a 3. Okay? All right, we are done with this video. You can go back and watch any part as many times as you need to, but don't forget to WSQ in your notes, and have a great day.